Today's lesson is going to focus in on unconformities, which indicate a series of geological events occurring. Before we get there, let's take a look at the other things that we've learned and quickly review. We're studying sequencing of rocks right now. Sequencing involves studying rock layers and formation, determining the order in which they occurred. We're using certain laws, the law of uniformitarianism, the law of superposition, the law of original horizontality. We're using clues like volcanic and meteorite clues, faults and folds, igneous intrusions and extrusions, contact metamorphism, xenoliths, and here we go, unconformities. All right, one of the papers I asked you to take a look at is called Formation of an Unconformity. And in this we have the pictures of a rock layer right here, a series of rock layers. And we're just using the law of superposition. The oldest would be at the bottom, the youngest would be at the top, and this would form underneath the water. Deposition happens. Next, something happens to an area. Some pressure happens. Either it gets pushed up, squeezed together, we get some folding. We call that uplift. Now, once that's uplifted above sea level, erosion wears away the uppermost levels. And you can see here we still got that fold in there, but the uppermost part, we call this truncated. It's been worn away. Now, if this area now submerges, we call that subsidence, new deposition can occur, and there's that line right there, that squiggly line. That represents the unconformity we see right there. So now we have new layers on top of there. This story would go something like this. Here's the oldest, next. Then the area is uplifted and folded. Then erosion takes place. Then we have subsidence taking place, and then we have new deposition. Okay, we'll take a look at this one over here. This next sheet for you to look at is called Note Sheet Unconformities, and it works like this. An unconformity is a buried erosional surface. It represents a gap in the geological time and missing rock layers. The steps for it to happen: the uplift of rock layers above sea level must happen. Some erosion of the rock layers must happen too. We get subsidence of rocks below sea level, and then the deposition of new rock layers on top of the old ones. Now, there are different types of unconformities. One type is called an angular unconformity. And in an angular unconformity, what we're going to see is that layers were deposited horizontally, and then uplift occurred. It caused those layers to become tilted. And then once that was exposed to the atmosphere, then we got our erosion, then the area subsided, and we have new deposition on top of it. So I just named some of the layers in here. You can see them like this. And here's how the story would go for this. We would say sandstone was deposited first, then limestone, then shale, then conglomerate. Now, they would have been deposited horizontally, but they're now folded, or you can see they're on an angle. So the next thing I wrote here is they were folded, uplifted, and then we have the erosion happening there. Then we have subsidence and new deposition of sandstone and limestone. That's one type of unconformity known as an angular unconformity, and you see that when you see this area truncated like that. Then we have what's called a disconformity. This is a type of unconformity that occurs when horizontal rock layers are on top of other horizontal rock layers, as shown in the diagram below. So we have horizontal, horizontal, horizontal. But here's what we see. We see the unconformity, the squiggly line that we see here. So if I were going to go through the story here, I would say we had sandstone, conglomerate. After that, we had some uplift occur. That gave a chance for erosion to happen. Then we had subsidence, new deposition of shale, and new deposition of limestone. Now we have the third type of unconformity. It's called a nonconformity. This type of unconformity occurs when sedimentary rock layers are on top of non-sedimentary rock layers, as shown below. So you can see we have igneous rock here, And there's that wiggly line here. This means there was an erosional surface. So this igneous rock was definitely uplifted. After it was uplifted, it now has some erosion happen to it, and we have some layers above it. So that means that there must have been a period of subsidence happening here, and then we see some sandstone and some shale. So you look at the back picture here, you can kind of get an idea just looking at from the bottom and working around that. Here's your layers here. There was some uplifting, some tilting went on right over here. After that was eroded away. Top of that was eroded away. Then we had a period of subsidence. We get some new layers deposited on there. This is the angular unconformity. You can see that because this area was truncated, and that's going to be locked in the rock record. All right, so what I'm going to ask you to do for homework tonight is questions on relative dating. Print this out, and the questions here you can actually see right there. There's an unconformity right there. So here's what you can do to hand this in. You can either send me back a copy of this. If some of you have a way to make a copy of this and send it back as a whole folder or whole file, you can take a picture of the pages, or you can just take a picture of the bubble sheet right here and send me back the bubble sheet. All right, thank you so much. Have a great day. Bye-bye.